Hello, geometry students. This is lesson 1-3. This is the lesson that I would like you to take notes from. So if you don't have your notes out, please get them out. And here's your title for today. 1-3, segments, rays, parallel lines, and planes. Anytime you need to stop this video to take something down in your notes, please do that and then just go on. So our first word today is segment. It's a little bit like a line. It's part of a line. It's part of a line with two endpoints. So this line segment up here could be named AB or BA. So either endpoint can go first. That's interchangeable. A line segment has a beginning and a middle and an end. And this could the beginning, the middle, the end. Those are interchangeable for beginning and end. Definitely has a middle called the midpoint, and that's something we'll talk about this year. So segment is part of a line. There's another part of a line. It's much different than segment though. And part of a line is ray. It's part of a line with one endpoint that goes forever in one direction. So this is ray YX and this is ray AB. I drew two of them because I wanted you to see no matter which direction the ray is headed, we're still going to put the symbol for ray like this. We're going to head it to the right. So this is ray YX and this is ray AB. And so we're putting the endpoint first. I even put not BA there. You cannot name a ray by just any letter that's on the ray. You have to name it by the endpoint. Because when we call a ray YX, that means we're starting at Y and we're going in the direction of X forever. The only way this would have another name is if we had another point. You know, maybe Z is right here. Then we could call it YZ, or we could call it YX because we're starting at Y and we're going forever in this direction. Next up is opposite rays, so we're branching off of rays. If we have two rays and we put them together back to back so that they're going opposite directions, they look like a line, but we call them opposite rays. So this definitely looks like a line or maybe a straight angle, but if you look closely, you can see the opposite rays. If we start here at A and go forever this way, that would be ray AB. And if we start here at A and go forever this direction, then that would be ray AC. So if we have two rays that are back to back, then they're called opposite rays. They look like a line. Next up, I have a cube, and I've got some lines identified on this cube, and I have made a statement here. Lines that do not intersect may or may not be coplanar. We're talking about that because we're trying to bring in parallel and perpendicular and skew and kind of their relationship to each other. Parallel lines are always going to be coplanar, and so are perpendicular. But what if we have some really strange lines that don't have any of those things? You know, they're not coplanar, so they're not parallel, they're not perpendicular, just kind of out there somewhere. What do we call them? What do they look like? So if you don't remember, this upside down capital T is the symbol for perpendicular. The double ones or an 11 or, you know, just two straight lines is the symbol for parallel. So my first statement is line P is perpendicular to line M. So here's P, here's M. They're crossing at a right angle. That means they're perpendicular. Line M is parallel to N. M and N. Now I said that parallel lines are coplanar. These don't look like they're on the same plane, but you have to imagine the plane that would go right through the center diagonally of this box and hit both of those planes. So it would go right through here. And we talked about planes that can intersect a box like right in the middle, and we've even drawn some of them in the last few days. And then finally we have for the last statement, line P is skewed to line N. So this is what skew looks like. Here's P, and here's N. You know, they're not on the same plane. This is a plane that's, you know, up front. This one is touching a plane maybe that's here or here or here, but it's back here. And so these are not going to be on the same plane. They're not parallel. They're not perpendicular. They're not on the same plane. They kind of look like they're going to intersect, but they're not going to, right? Because this one's further back and this one's up front. You have to think three-dimensionally. This one and this one are not going to intersect. So what do we call them? Well, we have a special word for them. They're called skew. Skew lines are just those lines that kind of float out in space and really don't have any relationship to each other. Let me show you another set of skew lines on this picture. If I stick with this one here, another line that's skew to this one would be this one up front, right here. That would be skew. Another one would be this one right here. You know, think three-dimensionally. You know, this one's coming out this way. This one's coming up this way. They're not actually going to intersect, even though if I drew it in, it might look like they intersect here. But three-dimensionally, you have to think about, and they're not going to intersect. Okay, so skew lines, here's the definition. Non-coplanar lines that are not parallel or intersecting. So get that down. Next up is parallel lines and parallel planes. This is at last, actually. For a long time, you've seen this picture, and we identify parallel lines by doing this. We also need to make sure that we can identify them maybe like on a cube, but parallel lines are always coplanar. I even put them here on a nice little plane. And then this is what parallel planes look like. So any opposite sides of a cube would be parallel. We can find them on other shapes as well. Okay, move on to the second video. The second video will get you prepared for your homework today.